All right, we are going to go over practice exam 2. This exam should be easier than the last one, in my opinion, but maybe I'm wrong. We'll see. We're going to start out with basic shapes of basic graphs. So an x squared graph looks like this. And you may or may not need to stretch it vertically. So one point that you should know is over 1 and up 1 in both directions hits the graph. 1 squared is 1, negative 1 squared is 1. And that's going to be kind of a common theme in all of these graphs. If we had x to the third, then it's going to look like this. But that over 1, up 1, and over 1, down 1 pattern still applies. Okay? If it's not that, then you're going to need to put a number in front of the x, like times it by 2 or divide it by 3 or something like that. Okay? Another common one is the square root of x, and it looks like this, and it's just 1/2 of a sideways parabola, so the over 1, up 1 rule still applies. What other one are you going to see? You might see the third root of x. And the third root of x is just a sideways cubed x cubed. So it looks like this. And the 1, 1 pattern still applies. So if it's over 1, up 1, or over 1, down 1, then the coefficient is always 1. If it's not 1, then you'll have to put a number in front. And I'm not sure if they're going to do that to you. Hopefully they won't. Okay, so problem number 1 says, what's the equation? Well, they've given us 3 points, which is kind of nice, but we don't really need them. We have the over 1, up 1 pattern, which means the number in front of the square root is going to be a 1. And we have shifted left 4 and down 3. So it's going to be the square root of x. How do we shift left? Plus 3. And how do we shift down? Oh, 4. And then minus 3. We good? Piece of cake? So let's plug an equation in there and see what happens when we get it wrong. Can I do another one? Try again. Give up. How do I do another one? That's the same problem. Okay, let's try that. Finish. Yes. Retake, 0%. Good job. Start. Okay. So which graph is this? X to the third. Do I need to put a number in front of it? No, because it's over 1, up 1, over 1, down 1. So my these are called parent functions. The parent function is x to the third. So the child function would be x plus 2 to the third minus 4. Okay? Did I count it wrong? No? Okay. So this would be the vertex, which is left 2 and down 4. What if it was over 1, up 3? What would you do? You would have to put a 3 out here, because it's 3 times as tall. Okay? The tricky part, and I don't know if they'll do this to you or not, is what if it's divided by 4? Then it's over 1 up a fourth. Or another way to do it, so it would look kind of like this. So over 1 up a fourth is kind of hard to see, but it actually works out that over 4 up 4 matches up. Yeah, I didn't do it right, but my graph is wrong. So you have to separate your idea of x and f of x. So if we move left or right, the x changes. So I have to replace x with x plus 2. And that has to sit underneath the third power. But any vertical movement happens after the third power, so that would be on the outside. That's a good question. Okay. Let's do item 2. How would we graph this? Oh, that's cruel. Whatever. I guess that's just what they're going to do. So left 3. And then down 4. Oh, that wrecked my line. All right. So left 3, down 4 right here. This is no bueno. And then I need to make it 2/3 as tall. How do I do that? Oh, that's not nice. That's a good idea. So normally it would look like this. But 2/3 x squared. If I plugged in 1, then I'm going to get 2/3, which is kind of nasty. So let's plug in a number that will it will end up simplifying. So let's plug in 3. So 2/3 times 3 squared, that simplifies to be 6. Which means when we go right 3, we go up 6. And then we can just transpose that into this position. So we go over 1, 2, 3, and up 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. That's a good question. Let's figure it out. Did I do that right? 3. So it's 2/3. Yeah, that's right. All right. So I'm assuming I have some. So right there. And then 1, 2, 3, 1, 2, 3, 4, 5, 6. There we go. What if I get it wrong though? Yay! So that's kind of annoying. If it said, if it was like 4x squared, that's really easy. So if we started here, you would just go over 1 up 4. Okay, so if it's a whole number that you're multiplying by, it's just over 1 up 4. If it's a fraction, like 1/5, then that is over 1 up a fifth. But you can't really graph that. So instead, and this is weird, you think it would be over 5 up 1, but it's not. It's actually over 5 up 5. 5. Well, because it was 2/3. Of course, you could just double that. Yeah. Yeah, that makes sense. So 2/3 x squared. The 1/3, this much, would be over 3 up 3, and then the 2 makes it twice as tall. So yeah, that works. Good thinking. I've never thought of it that way before. But yeah, that was way easier. They don't normally ask you to graph a fraction that doesn't have a 1 in it. But anyway, I guess we're in college now. Okay, 3. So the graph shown is f of x. We want to graph -1/2 f of x plus 3 minus 1. Now that looks really complicated, but it's not. So if we look at the movements, this is left, this is down, and what does that do? It's a flip which way? Flip across the x, and half as tall. Now, the order you do these in is going to affect your answer. What order should we perform these? From the inside out. Start with x and work your way out using order of operations. So, left 3. So I take all 3 points and I slide left. And now I have this figure. Then what? Not down 1. Flip it and the 1/2. Does it matter which one I do there? Nope, those will be the same. It doesn't matter the order of flip and then make it shorter, or shorter make it and flip it is going to be the same thing. So this point is going to move to here, and then it's going to go half the distance to the x-axis. So right there. Everybody understand that? Flipped, and then I make it half as tall. So this one is going to flip to here, and then cut it in half. Oh, right there. And then we cut it in half to there. And then this one flips to there, and then we cut it in half to there. And now I shift the whole thing down 1. Now, if you are a visual person, that made a ton of sense. If you're not a visual person, your head almost exploded. Okay, there's another way to do that. We have the formula. And we also know the x and y values. So this point is 3, 2. So when I plug 3 in here, what value do I end up with? So -1/2 times 3 plus 3 minus 1, that's 6. -1/2 of 6 is -3 minus 1. What did I do wrong? I did something wrong. 3, 2. Plug in 3. 3 plus 3 is 6. Because we ended up right here, didn't we? Oh no. So we went left 3, upside down, and then half as tall. I ended up right there. Oh, down 1. So -2. So I should end up with -2. -6 divided by... Not sure why that's not working. Let me try a different one, see what happens. Alright, so -1/2. Oh! I know why that doesn't work. what does this do? I don't know. So if we had the equation like it was a squared equation or a square root, that's the problem. I don't have the equation, so I can't plug it in. So if it looked like this, this tells me what the function looks like. But I don't have that information here, which is why I can't do it. So I lied, won't work. Do you guys want to see that movement again? So starting on the inside, left, this one is upside down and half as tall. And then this one is down 1. So we need to do that movement for each of the points. Actually, we need to do the movement for all of the points. But since it's a straight line, I can just do the kind of the endpoints, and then the rest will just follow. So left 3, right there. We need to flip it upside down. Goes to there. And then make it half as tall, which means I cut my distance to the x-axis in half to there. And then I go down, down 1. So I end up right here. Okay. This one gets moved left 3, upside down, cut in half, and then down 1. Okay, this one gets moved left 3, upside down, cut in half, and down 1. And that would be the new figure. And then you just play connect the dots. Okay, circles. Circles, up until this year, were not part of this class. Sometimes they put them in, sometimes they pull them out. There are actually a whole set of equations that are sort of based on the vertex equation of a parabola. They're called conic sections. And we don't even, in years past, we don't even look at that chapter in the book. So I just have to give you a crash course in circles, and they're actually really, really easy. Let's do this. So a circle equation, if I have y equals x squared, that's a vertical parabola. It could be a happy parabola or a sad parabola. If I have x equals y squared, that's a sideways parabola. And their conic sections are some version of x squared or y squared or both. And it turns out that if you have an x squared and a y squared, and they have the same sign, then those are circles. Okay? And the basic equation of a circle is x minus h squared plus y minus k squared equals r squared. And you'll notice that hk is the same set of, it's the same point that we used here. To graph parabolas. Okay, so hk is the vertex of a parabola, and hk is the center of a circle. So if I had x minus 3 squared, and then y plus 2 squared equaled 9, that circle is very easy to graph. Anything inside parentheses works backwards. So right 3 and down 2, and then my radius is 3. Does everybody understand that? And now drawing circles through 4 points is a lot harder than you think. Wow. That's pretty good. Does that make sense? Okay. What would the equation of that circle be? Oh, oops. I didn't mean to make them both 3. So x plus 3, because we're left, squared, plus y minus 3, because notice, yeah, because it's inside, it's backwards, equals 4. It's square it. Radius squared. Now, there are 2 other graphs that we're not going to look at. One of them, instead of x squared plus y squared, it's x squared minus y squared. And that looks it looks like this, which sort of looks like 2 opposing parabolas, but they're not actually parabolas. They're shaped differently than parabolas. And the other one is what we call an ellipse, kind of an egg. And that's a circle that has 2 radii instead of 1. So a circle, the radius is the same in every direction. But if we divided this one by, say, 9, and we divided this one by, say, 4, then we have a radius of 2 in this direction, and we have a radius of 3 in that direction. And those are the 4 conic sections. Parabolas, circles, the funny opposing parabolas, that's called a hyperbola, and then an ellipse. But we're only dealing with parabolas and circles. But the other ones do show up quite a bit. Just not in this class. All right, so let's go back here. Draw a circle. Well, how far left and right do we go? 0. But I do need to move up 2. Okay, and then what's my radius? 2. So, super easy. Okay? So, write out an equation for a circle that contains a diameter with endpoints -4, -2, and 2, -6. So this is a little bit harder. So let's remember those. -4, -2, and 2, -6. So -4, -2, and 2, -6. All right, so we're in quadrant. All right, got it. So 1, 2, 3, 4. 1, 2 right here. And then 1, 2, 3, 4, 5, 6. Okay. So that is a diameter. What does that mean? That's from one side of the circle to the other. Wow. Okay. So we need to figure where is the center of the circle and how big is the radius. And then we can fill the equation in. So, right, the halfway point is going to be the center. Okay? And then half of the distance of that line is going to be the radius. Now that seems really complicated, and there are formulas, but I don't memorize the formulas because just reasoning through it makes a lot of sense. There's not much room up here, so I don't memorize these formulas. The midpoint will always be the average of the x's and the average of the y's. The average, it's the average distance. So how do we find a distance between two numbers? You take the big one and you subtract the small one, right? What if one of them's negative? It turns out it doesn't matter. If you take one number and you subtract the other one, you will get the distance. And then we just cut that in half to find the halfway point. So what happens when I find the distance between the x's and then cut it in half? Well, if I get -4 and I subtract 2, that's -6, and I cut that in half, I get -3. What if I do it the other way around? What if I do 2 minus -4, I get 6, and cut that in half, and I get 3. Okay, so this is how you find a distance. So what does, in both cases, distance is positive. So what are those telling me? What does 3 mean? I need to move over 3. Which way? From both sides, right? So what that is telling me is this distance right here is 6. And so this distance right here is 3. But if we take the actual average, we'll get that number anyway. So distance uses subtraction. Averages use addition, right? What is the average of -4 and 2? -4 plus 2, wow. -4 plus 2 is -2, and then I cut that in half. Why do I cut it in half? There are two numbers, and I get -1. So you don't need to remember any formulas, but there are two ways to find this. If you find the distance between the two x's and cut it in half, that will tell you how far you need to move to find the middle. But that's a little bit more work. Instead, let's just find the average, and it tells me this point is -1 comma something. What should we do with the y values? Add them together. -2 minus 6 is -8. Divided by 2 is -4. Now my graph is terrible, but there we go. So that is HK, is -1, -4. I have half the equation done, more than half. X plus 1 squared plus y plus 4 squared equals the radius. There's a formula called the distance formula. I don't memorize the distance formula because the distance formula is just the Pythagorean theorem. So we have two options. Either we build this triangle, which we already know is 6 and, is it 4? Yeah. Or, what else could I do? Oh, if I use this and I calculate hypotenuse, what do I need to do with the hypotenuse? Cut it in half. And those numbers will be big. What's an easier way to solve this? Use a smaller triangle. I asked for red. Apparently I can't have red. And the side lengths of that triangle are a 2 and a 3. Do I need to cut that in half? No. So 2 squared plus 3 squared, that's 4, and 9 is 13, and I take the square root of that, and it's just the square root of 13. So R is root 13. But